that are going to be about it. All right, so next we're going to be talking about vector concepts. So recall that this is simply known as just a line segment. The circumference of a circle is 2 pi r, and the area of a rectangle is length times width. So what these are is these all possess only magnitude and are called scalars. So other examples are age, temperature, mass, time, and energy, and volume. The reason why they're called scalars is because there is no direction. No direction. Smiley face. So a vector is a quantity that possesses both magnitude and direction and is represented by directed line segments. Examples of quantities that can be described by vectors are forces, velocities, weights due to gravity, momentum, and friction. So the ending part, or the start point, is called the tail or the initial point, and then where the arrow heads to is called the terminal point, a tip or a head. How many of my physics people got sick and tired of drawing those force diagrams with vectors where the force is acting down on the box, but is also acting to the side of the box and to the left side, but you also have another dumb vector that you can be going down to make a right angle triangle to help you solve for the friction and all that fun stuff. Okay. So it's not going to be that complex here. It's going to be pretty easy. Okay. I know you guys probably had a headache with that, but that is the reality of physics. So note when drawing vector diagrams, the length and the direction of the line segment should reflect the length and the direction of the vectors represented in my diagram. So again, very much intro topic stuff for vectors. Someone say something or unmute their mic. I think I heard someone unmute their mic. Never mind. So vector notation. So often it is important to specify the head and the tail of a vector. Then the vector is written as vector AB, where A is the tail and B is the head, okay, which is the end part of the vector. These are called point-to-point vectors. So vectors can also be denoted by a single lowercase letter in any of the following ways. So in boldface or older text, which is U and V, you can have it topped with an arrow or half arrow, topped with a bar or underlined. This is what we will probably use, is the one with the arrow on the top. So a vector must have a magnitude and a direction. However, if a vector is in a position that is not fixed in space, such vectors are called geometric or free vectors. Often we need to know the magnitude or length of a vector, which is denoted as the magnitude of vector U. In other words, the magnitude of vector AB is equal to the magnitude of vector AB, and the magnitude of vector U is equal to the absolute value of U. So the magnitude is always positive in this case. So again, we'll do a couple more definitions and then we'll get to a last example. So equal vectors, or two vectors A and B, are equal if and only if they have the same magnitude and direction. So for example, this is vector A. This is vector B. They are equivalent because they have the same magnitude and are going in the same direction. Opposite vectors are vectors that are opposite if they have the same magnitude but point in opposite directions. When two vectors are called opposites, such as vector A, vector AB, and vector CD, one is called negative of the other. So vector AB is equal to negative vector CD, and vector AB is equal to negative vector BA. So for parallel vectors, two vectors are parallel if their direction are either the same or exactly in the opposite directions. So I can have one vector starting from here to here, but it can also be parallel if I draw it the opposite direction as well. They are parallel, but they are moving in opposite directions as well. So the magnitudes may or may not be the same for this one, but as long as they're parallel, that is completely fine. Or an example of that where the magnitude isn't the same, you have this short little dinky vector over here, but this one is bigger by twice the size. But because they are parallel and they move in opposite directions, they are considered to be parallel. Even though one is bigger than the other, they will never meet or touch. So again, I'm giving you an easy day today. So example 1, a driver travels 3 kilometers due east. So 3 kilometers due east. This would be my vector u. And travels 5 kilometers due north. So the new vector starts from here and goes up here. Represents these displacements on the vector diagram. Use a scale of 1 centimeter is equal to 1 kilometer. So I have the magnitude of u is going to be 3 kilometers or 3, and the magnitude of v is going to be 5. That is as simple as it is going to get at this point in time. So now we get to the annoying stuff. So in the diagram on the right, name all equal vectors. So let's label them using my marker. So vectors that are equal to each other are vector AB is equal to vector DC, which is equal to vector EF, which is equal to vector HG. So those are what we would call equal vectors. Now, we can also look at the vertical lines and look at the vertical vectors, which means that vector AE is equal to vector BF, which is also equal to vector DH, which is also equal to vector CG. And we can also look at the width of my prism. So from A to D. So from A to D, that is the same thing as writing B to C, which is equal to E to H, vector EH, which is equal to vector FG. So as you can see, those are all the same vectors or equal vector because they are going in the same direction. Now for B, I need to name 2 pairs of opposite vectors. So who can name me 2 pairs of opposite vectors in this prism? Let's see, you can come up with the negative vectors for this one. Yep, so vector AD is equal to, if it wants to be opposite, negative, AD is equal to negative CB. Okay? Because if I go from vector AD, I'm going this way. In order for BC to be opposite, I need to go the other way. So it'd be negative BC, sorry, negative BC. Can anyone else give me another pair of vectors that are opposite to each other. They give me the same magnitude, but they are going in opposite directions. So EH, vector EH, is opposite to negative FG. Perfect. That's what we really need to look for. Second last example, find the magnitude of U rounded to the 2 decimal places. So I have 2 sides of an angle given. So I need to find the magnitude of U. So I have 115. This whole angle here is 115. However, I have this angle will be 65 because 180 minus 115 gives me 65 degrees. So this opposite side is 12 centimeters and this opposite side is 5 centimeters. So I know one side is U, which means this whole blue line right here is going to be 2 times the vector U. So now if I highlight this triangle over here, how am I able to solve for vector U, or what the magnitude of it is? What law am I able to use? So I have a side here, and I have my angle, which is 65. So what law can I use where I have 2 sides and a contained angle? What law is that going to be? Anyone? Cosine law. So I have magnitude of 2u squared is equal to 5 squared plus 12 squared minus 2 times 5 times 12 times cos of 65. What I get here is approximately 118.2858. So once I square root that, I get the magnitude of 2u is equal to 10.58759. But because I want just the magnitude of u, I need to divide both sides by 2. Which means that my magnitude of u is going to give me approximately 5.44 centimeters. So guys, is there any questions about the first 2 lessons on vectors so far? Or does it look like it's going to be pretty straightforward? Any questions, thoughts, concerns? Example 4, I'm going to leave it for you guys to do alone. And then I'll check up on it. It's just a diagram that you're going to be drawing. So you should be able to figure this one pretty easily. Okay, so basically you're just drawing the opposite of what southwest is. And what's the opposite of southwest? Let's see, you can answer it right here. What's the opposite? Northeast. Perfect. So that would be so you would just draw a vector